Question 1. A certain type of bacteria increases continuously at a rate proportional to the number present. If there are 500 present at a given time and 1,000 present 2 hours later, how many will there be 5 hours from the initial time given? This is an exponential growth problem, so we are going to start with y equals c e to the kt. The c, since we are 500 present at the given time, that will be our c value, so we'll have y equals 500 e to the kt. There are, remember our step process, we're going to find c, find k, and then solve the problem. So we found c, now we're going to find k. We know there are 1,000 present 2 hours later, so my y will equal 1,000 when the time is 2, so I'll get 2k up there. I will divide both sides by 500. That will give me 2, so I'll get 2 equals e to the 2k. I will then take the natural log of both sides, so I'll have natural log 2 equals, we get to bump the 2k out front, so 2k ln e is 1. Then to solve for k, we'll just divide both sides by 2. So k is equal to ln 2 divided by 2. So now my formula is y equals 500 e to ln 2 divided by 2 t. So I've found c, I found k, now I'm just going to solve my problem. How many will there be 5 hours from the initial time given? 5 hours is a time, so I'm going to put that in for the t. 2 over 2 times 5. If I plug that all in my calculator, I should get an answer of 2828.427, and then my label would be bacteria. Please notice that I did go out to 3 places on this problem. Question 2. A certain substance has a half-life of 5,730 years. If there is a bottle of the substance in the science workroom, what percent of the substance will still remain after 100 years? Okay, this one is talking about exponential decay. So again, I can use y equals c e to the kt. It doesn't tell me how much substance that I started with, so I'm going to just let my c be 100. Again, it doesn't matter. So again, my process, we're going to find c, we're going to find k, and then we're going to solve the problem. So I do know the substance now has a half-life of 5,730 years. So I know that in 5,730 years, whatever I started with will be cut in half. So if I started out with 100, I will now have 50, and that will be after 5,730 years. Okay, now I'm going to divide by 100. So I'll get 1/2 or 0.5 is equal to e to the 5,730 t. Then from here, we'll take the natural log of both sides. So this should be k at this point in time. And then, so I'll get ln 0.5 equals 5,730k ln e. Ln e is 1. And then to get k by itself, we'll just divide both sides by 5,730. So k equals ln 0.5 over 5,730. So the next thing that I would like to do is I've got y equals 100 e to the ln 0.5 over 5,730 t again, and this says what percent of the substance will still remain after 100 years. So 100 years, again, they were giving me a time, so that would equal 100. So if I just plug that into my calculator, I should end up getting 98.798%. Alrighty, question 3. To keep himself awake studying, John decided to buy himself a case of Mountain Dew. Unfortunately, 7-Eleven only had warm cases left, so John bought several bags of ice to chill at home. When John got home, the temperature of the Mountain Dew was 76 degrees, so he packed it in the ice. After 10 minutes, the temperature had cooled to 70 degrees. If Mountain Dew is best served at 60 degrees Fahrenheit, how long did John have to wait to enjoy his Mountain Dew? So we're going to be looking for a time. So I know that I will be finding C, I'll find K, and then I'll solve the problem. Right, since we have his Mountain Dew cooling, we get to use Newton's law of cooling, which is the temperature of the object equals C e to the kt plus the temperature of the medium. We know that the temperature of the medium is going to be the ice, which will be 32. Okay, first of all, we're going to find C. When he first bought his Mountain Dew, it was 76 degrees. So the temperature of the object was 76, and that was when time equaled 0. So I'm going to subtract 32, and that gives me that my 44 equals C, just C equals C. So now we're going to get temperature of the object is equal to 44 e to the kt plus 32. So I found C. Next I'm going to find K. I know that after 10 minutes the Mountain Dew had cooled to 70. So the temperature of my object will be 70, and then 44 e to the 10k, because I'm putting in 10 for the t. Okay, I'm going to subtract 32. And when I do that, I'll get 38 equals 44 e to the 10k. And then I'm going to divide by 44. So I'm going to reduce that. You don't have to, but I'm going to get 19 over 22 is equal to e to the 10k, and we would not don't want to make that a decimal because it's not a nice one. I'll then take the natural log of both sides. So I'll get the natural log of 19 over 22 is equal to 10k ln e. Ln e is 1, of course. And then to get k by itself, we'll just divide both sides by 10. So if I rewrite this, I'm going to get t sub 0 equals 44e. My k is the natural log of 19 over 22 divided by 10, t plus 32. And then it says, how long will John have to wait? The Mountain Dew is best served at 60, so we want to know when will the temperature be 60. So we'll put that in for the temperature of the object. So I'm going to subtract 32. And when I do that, I will get 28 equals 44 e to the ln 19 over 22 divided by 10t. And we'll divide both sides by 44. And again, I'm going to reduce that, although you don't need to. Actually, it's going to reduce to 7/11 equals e to the ln 19 over 22 divided by 10t. Just like normal, we'll take the natural log of both sides. We'll get the natural log of 7/11 equals the natural log of 19 over 22 divided by 10 t ln e. Ln e is 1. And now we could either divide both sides by the ln 19 over 22 divided by 10, but I'm a fan of multiplying by the reciprocal, because some people end up with some fraction difficulties when they do that. So 10 over the natural log of 19 over 22. And when I do that, I should get 30.830 minutes, or if you wanted to be exact, that would be 30 minutes and 50 seconds.